The last section of chapter 3 deals with intersecting curves. Here's an example. We have a light pole which is 20 feet east and 40 feet north of some intersection. Because I'm given a position relative to this intersection, I'm going to make this intersection the origin. So I have an x and y axis. X here is representing east in this direction, west in this direction, north and south. And we have the light pole is 20 feet east and 40 feet north. Let's say here is our light pole, 20 feet east and 40 feet north. Each of these notches is, of course, 10 feet. And what we have is that this light pole is producing light with a diameter of 120 feet. In other words, with a radius of 60 feet. So let's see if we can draw this. Here we're at 40. It looks like the circle would reach to here at the bottom. I don't think that my circle or my notches are very to scale here, but I've drawn 6 around like this. And let's see this direction, 1, 2, 3. So I can connect to make a circle, or something slightly resembling a circle. And what we're interested in is what portion of each street is illuminated. So in particular, here we have a street, this east-west running street, which is illuminated from, well, it's unclear exactly where these points lie, but something like from here to here. And similarly, on this north-south street, we have something like from here to here is all lit up. So in order to identify exactly how much of this east-west street is lit up, we want to identify this point and this point. So how can we do this? Well, we know that these 2 points lie on both this line and this circle. So if we can write mathematical descriptions of that line and that circle, we can use them in order to find these 2 points. So our line is quite straightforward. Because of our choice of the origin being here, we can represent this line, this street, as simply the collection of points where y equals 0. And we can represent this circle, well, what do we know about this circle? We know that it is centered at 20, 40, and its radius is 60. So we can write this. Now, I want to use these 2 equations in order to specify a couple of specific points. So how do we do this? We take our equations and we find a way to combine them. We can do this either using a technique like substitution or a technique like elimination that you should have seen in algebra. Here, we're quite set up to use substitution. We know that y equals 0, so we can plug in y equals 0 and use this equation to solve for x. I'm skipping a step slightly here. I'm going to move this over to the right-hand side here after plugging in y equals 0. So on the right-hand side here, I now have 60 squared minus 40 squared. 60 squared is 3,600. 40 squared is 1,600. So this difference is 2,000. Subtracting 2,000 from both sides, and we can solve for x here by using the quadratic equation. 8,000 is 400 times 20. The square root of 400 is 20. And 20 I could write as 4 times 5, which means that this term here is 2 root 5. So I have that this looks like, So I have two answers here, 20 plus 20 root 5 and 20 minus 20 root 5, which is consistent with my picture where I have two numbers, one of which is some distance more than 20, and one of which is the same distance less than 20. So I do want to make sure that this feels reasonable to me in terms of the scale of my answer. The square root of 5 is a little bit more than 2. Maybe 20 times that is maybe something like 45. So this would be 20 plus 45 and 20 minus 45. We're looking at 65 and negative 25. And looks within a ballpark of my terrible picture. With a more accurate picture, it would be more easy to tell whether this answer seems reasonable. But I feel pretty confident in this answer. For the vertical north-south street here, I'll let you read the book. Working through it is really the exact same process. The only difference is we're plugging in x equals 0 instead of y equals 0, because we're looking at this vertical line, x equals 0, as opposed to this horizontal line, y equals 0.